I love this last one. Let me show you how to do it in case you're stumped. So tan x, this is the ratio of tan x. So we know that's a side of opposite over hypotenuse. Wait a minute. How's that opposite over hypotenuse if it's just x? Well, it means that it was a ratio as x over 1. You might want to, now knowing that that's opposite over adjacent, you may want to stop and try it on your own. But if not, here it is. So tan inverse has to be positive, x is positive. So that's either quadrant 1 or 3. But since tan is restricted to just quadrants 1 and 4, it can't be in the third one. So here is the first quadrant. The opposite is x, the adjacent is 1 right here. And then the hypotenuse, how would we find that hypotenuse with just a 1 and an x? I guess we could do the Pythagorean theorem. 1 squared plus x squared equals c squared. So then I would need to square root both sides. And then I know that this hypotenuse would be 1 plus the square root of x. Okay, well now we got the side lengths in a formula, but at least we have them in terms of x, which I think is so cool. I like doing math like this where there's not even numbers involved. Now I got to find the sine of this triangle, and so the answer for the sine would be the opposite would be x over the hypotenuse, and then that would be the ratio. But I do have a square root in the denominator, so I should not leave that as my final answer. I'll rationalize that. And this gives me x, 1 plus x squared over 1 plus x squared without the square root. That's the final answer. Whew!